Hi, welcome to the first of this week's mini lecture videos. This week we're going to concentrate on understanding probability. We're going to define the basic terms and look at the basic rules. You may have seen all this before or some of it before, but watch the videos to make sure we've all got the level starting point for the other work we're going to do. Basic definition of terms. First of all, an experiment. And an experiment is a process of measurement or observation. This could be in a lab, in a factory, but it's also a theoretical idea, so it could be an abstract experiment that we just do in our minds as well. Randomness is a key word, and that's where chance effects happen, which mean we can't predict the results of something exactly. A trial is an instance of a single performance of an experiment. So the experiment defines what you do, and then each time you do it, you're doing a trial. And each trial will be a bit different because of randomness, random effects, which make each one a little different. The sample space, S, of an experiment, that is the set of all possible outcomes. So everything that could happen from that experiment is what defines the sample space. And so we can picture that here. Other things in the world can happen that are outside the sample space, but for this particular experiment, whatever happens, it must be within here. So each time you do a trial, you'll get an outcome or a sample point from that trial. And so we can see that that outcome or sample point must be within the sample space S. And we can identify that there. And repeating trials means we're going to get more outcomes. And so here for each trial we get another outcome. And the sample size is the number of outcomes, and here the sample size N is 4. Then events are subsets of the sample space S. Like this one, for example, here's an event E. So an event is something that can happen from the experiment, and it's a defined range of things that can happen. So you can do the experiment, and you may get the event you're looking for here, or you've defined, or you may get an outcome that is not the event that you're looking for. And so you can divide up the subspace, you can divide up the sample space with different events. Okay, a little bit more on definition of terms. We saw in last week's lectures that we were doing histograms and we were creating intervals, and the interval you'd allocate each data point to one of the appropriate intervals. And in some of the samples we did, some of the examples we did, we had intervals which were carefully selected so that all of the data points fit neatly into one of them or another of them. But you could have an instance where you have an interval boundary and your data value is equal to that interval boundary, and then you need to be able to define clearly whether the data point would fall in the left hand or the right hand side of that boundary, which interval it goes in. And so we can write rules for that, and here's a little bit of notation just so you're familiar with it, notation of how we do that. So here's a variable, and in this case we're trying to define an interval which starts at A and includes the value of A and extends to infinity. So when we're doing that, we can write it with this type of interval notation that you might have seen before, and this says that the square bracket, that indicates that we are starting at this point, this value A, and including that value A, so that's A or greater than A, up to infinity. We have a curly bracket here because you can't include infinity, that never gets reached. So the curved bracket indicates that that's not included in the interval. We can write that in set notation, where our interval is x, where x is greater or equal to A. And then we can draw it pictorially, and we'd use a closed symbol, the solid dot there, to indicate that we're including A within our interval here. So you can see that notation. And then below it we've got a few more examples. If we're not including A, then we have a curly bracket for the interval notation, or in the set notation we just have a greater than, not greater than, equals. And here we have the open symbol. Going the other way, minus infinity to A, square bracket means we're including A, and that's a solid object, solid circle there, and so on. So you get the idea that we've got this notation. So this is here so that if you encounter it, you can read it correctly, and you can use it yourself as and when you need to. So a bit more about sample spaces of some random experiments. So these are some simple examples just to show actually how you can do this. So we're writing it in curly brackets like a set notation. The sample space of rolling a die, we call that sample space S, and the outcome of rolling a die can either be 1, 2, 3, 4, 5 or 6, and so that's all the possible outcomes that could be, and so that defines what the sample space is. The sample space is 1, 2, 3, 4, 5, 6. That's all the possible things. Another instance, octane rating of petrol might be something like this. This probably isn't exactly true, but it's a case where you could say, well, the octane rating, it's a value x, and x can be greater or equal than 85 but must be less than 95, and so we could write that in the interval notation like this. X is starting at 85 and it includes the value of 85 because they've got the square bracket, and then that goes up to 95, but it doesn't include 95 because we've got the curly bracket. I think there's one more. Yes, flipping a coin. Possible outcomes are a head or a tail, and so we have a simple binary outcome, head or tail. You can see two types of experiment here, one where you have discrete outcomes and one where you have a continuous outcome. So which ones are discrete outcomes? It's rolling a die and flipping a coin. In those cases we can write the sample space out just as a series of numbers, and there's a finite number of possible values it can be. Whereas something like an octane rating, this variable x is a continuous variable. It could have an infinite number of possible values, and so we have to define that in a slightly different way with those limits. That was sample spaces. Now we can just make sure we understand what we mean by events. Here we've drawn out our sample space for rolling a die. So we've got those discrete outcomes 1 to 6. This is an event, so we define what the event is. We're defining a certain subsection of the sample space defined by some particular rule. So here the rule is that our event A is when we have an odd number. So that means that the event is 1, 3 or 5, and we can recognize that on the sample space sketch. Likewise, even numbers is 2, 3, 4. Of course we can see that. Another event could be greater than 4, and then that would be 5 and 6, and so we can identify those. So we can see that we have different events within the sample space, each with its own definition, and of course sometimes these events will be separate from one another, sometimes they will overlap, and so we're interested in the next section, unions, intersections and complements of events. So we've got some words to describe exactly what we mean when these are happening. The union of two events, here we've got event A and event B, and the union is where you have the combination of all of A and all of B together. The intersection is when you are just looking at the subregion which is in both A and B, and so we have that as A intersection B. And the complement of A is illustrated here. So A is the region indicated by the circle, but the complement means you're taking the everything else that's in the sample space and is not in A. So the complement then becomes everything else in the sample space except what was in A. So those are some really useful definitions which enable us to analyse and understand quite a few problems and to write out some basic rules of probability. I think I missed one there. Mutually exclusive, A and B, where A and B are have no intersection. The intersection of A and B is the null group. Okay, and that finishes this short lecture defining terms. We've covered sample spaces, events, unions, intersections and complements. So we've just made sure that you understand those basic terms, and then we can use those in our future lectures. Next lecture we're going to look at the basic theorems of probability, so we'll define probability have a general definition for it, and then look at the theorems that derive out of that. Thank you very much.